Okay, so in this video, we're going to take a quick look at the quiz 5 solutions. And so number 1a, we had the function g of x equals x over 2 minus tangent of x. And we want to find the derivative. So the overall rule here is going to be the quotient rule. And so our g prime of x is going to be the derivative of the top, which is, well, we could write it as d over dx of x, right? That's derivative of x times the bottom minus the top times the derivative of the bottom. And you could even write it as, derivative of the bottom. Just to remind yourself, that's all over the bottom function squared. And so at this point, we can just fill things in, right? The derivative here is 1. And then the derivative here would be 0. And derivative of tangent is secant squared. So that'd be 0 minus secant squared x, right? So if we rewrite that, that's just going to be 2 minus tangent of x. Then we have a minus secant squared, or minus x. So that'd be a plus x secant squared, x divided by 2 minus tangent of x squared. Okay, so you can leave your answer in that form. 1b, h of t equals t e to the t secant of 3t. Now, if you have a triple like this, if you're taking the derivative of a triple product, we talked about this. You take the derivative of the first times the second 2 plus the first times the derivative of the second. So the derivative just kind of goes through each function like that. Okay, so when we're differentiating this, then we just differentiate each function in turn. And so h prime of x, or h prime of t, derivative of t is 1, so the first one's just going to be e to the t secant 3t plus t times the derivative of the second. Derivative of e to the t is just e to the t, so that's going to look the same. And then the last function is the secant of 3t, so t e to the t times the derivative of the secant. Now the derivative of the secant is the secant tangent, so in this case it's going to be secant tangent, leave those open, and then the inside function goes in both of those. That's 3t, and then the derivative of 3t comes out, and that's 3. Okay, so in this case, we did have a chain rule stuck in there as well. Good. All right, so you can leave your answer in that form. Let's see, 2c, 2c, or 2a, I guess, on the next page was x squared, or 9x squared plus y squared equals 9, and we want to find dy over dx. And so we just differentiate. So that's 18x plus, now this is f of x squared, right? So you're treating that as if it were f of x squared. So the derivative would be 2 times f of x times f prime of x. So this is derivative 2 times f of x times f prime of x. Yeah. Okay. This is, you could think of this as 2 times f of x to the 1 power, right? So I'm using the power rule on the f of x. So translating that back, right, we just have 2y, that's the derivative of the outside, times y prime, or dy over dx in this case, equals 0. Okay, so then just to solve for y prime is going to be minus 18x, it looks like, over 2y, or minus, minus 9 over minus 9x over y. You can simplify that if you want. Good. All right. The last one is 4 cosine x sine y equals 1. And so again, we're trying to find dy over dx. This is implicit differentiation. So this is a product first. So we take the derivative of 4x, which is minus 4 sine x, times the derivative of, or times the second function, plus the first function, times the derivative of the second function, And now the derivative of the second function is going to be cosine. That's the derivative of your outside. And then you put your inside function there. And then you multiply that times the derivative of the inside. Equals derivative of 1 is 0. Good. And so then you could just, it looks like the signs are going to be on top. And the cosine's on the bottom. Good. There it is. We didn't talk about these very much because it's the new material, but I wanted you to get a little bit of experience before the homework. So next time we meet, we'll talk about these more.